At nearly 12,800 feet above sea level, on a windswept, barren, and bitterly cold plateau in the Andes of modern Bolivia, lies a bewildering field of shattered stone. This place is known as Puma Punku. To a casual visitor, it may not resemble an ancient temple or a magnificent palace. Instead, it looks more like a vast construction site that was suddenly and mysteriously abandoned. Gray and red stone blocks are scattered across the ground. Some lie partly buried beneath the dust and sand of the windswept Altiplano, while others rest on top of one another, like pieces from a giant toy set left behind by someone who vanished long ago. For the past 120 years, since the first archaeologists began documenting Puma Punku systematically, the site has remained a deep fracture in our understanding of the past. Generation after generation of researchers has traveled here, carrying everything from measuring tapes and compasses to the most advanced laser scanners available. Yet many have left with more questions than they had when they arrived. No widely accepted theory has ever provided a complete and convincing explanation for every aspect of these ruins. The first problem begins with the raw materials themselves. Puma Punku was built primarily from two types of stone commonly found in the Andes: andesite and red sandstone. Andesite is an extremely dense volcanic rock, significantly harder than most other natural stone found in the region. Working such an unforgiving material would require tools of exceptional hardness, or an almost limitless degree of patience. Red sandstone is somewhat softer than andesite, but it is still a structurally durable material that does not easily yield to ordinary force. The presence of hundreds of blocks made from these demanding materials, scattered across a remote and windswept plateau, already presents a formidable challenge to our understanding of ancient transportation and construction. Yet what truly troubles the modern engineers and architects who visit Puma Punku is not the weight or hardness of the stones. It is the way they were shaped. Close examination of the surviving fragments reveals remarkably straight cuts, unusually flat surfaces, and right angles of extraordinary precision. The internal geometry of the blocks, especially the famous H-shaped stones, is so complex that no known structure from the same period anywhere else in the world appears to contain anything quite like it. These were not simply stones carved flat and stacked on top of one another. They appear to have been designed as modular architectural components, produced with an astonishing level of consistency and fitted with grooves, sockets, and interlocking joints. This exceptional complexity has led to one of the greatest failures in experimental archaeology: the attempt to reconstruct the original structure. At ancient sites damaged by time or natural disaster, such as the Parthenon in Greece or the palaces of ancient Rome, specialists can often use the surviving fragments to recreate plans or models of the original buildings. At Puma Punku, however, every attempt has reached a dead end. For decades, the Bolivian government has funded research projects designed to fit the scattered blocks back together at the site. International teams equipped with advanced spatial analysis methods have attempted the same task. Even when technology specialists use modern three-dimensional modeling software, entering precise measurements from every surviving fragment and allowing computers to search automatically for logical connections, the puzzle remained unsolved. The original design of Puma Punku appears to fall outside every architectural system that modern researchers can easily recognize. Perhaps a major portion of the structure was carried away or completely destroyed over thousands of years. Or perhaps the surviving blocks were never fully assembled in the first place. Whatever the truth may be, standing among the ruins creates an overwhelming sense of confusion, as though the site represents a sophisticated technical tradition whose chain of knowledge was suddenly broken. The conventional explanation has long maintained that Puma Punku was created by the Tiwanaku people, whose civilization flourished across the Andean highlands between the 5th and 10th centuries AD. According to the widely accepted historical account, Tiwanaku craftsmen possessed only stone tools, simple copper implements, and abrasive sand. They are believed to have relied on the manual labor of thousands of workers, striking the resistant andesite again and again with copper chisels and stone hammers, then grinding and polishing the surfaces over many years until each block reached its intended form. The mystery might have ended with those simple explanations. Yet, precise measurements combined with the repeated failure to reconstruct the original structure reveal an enormous gap between theory on paper and the realities of mechanical construction. How could a civilization working mainly with Bronze Age tools produce surfaces of such remarkable flatness, along with perfectly repeated right angles across hundreds of separate stone blocks? Could the silent stones of Puma Punku conceal an entirely different story, one that mainstream archaeology has avoided confronting for decades? To understand why Puma Punku has become such a profound puzzle, we must first examine the Tiwanaku civilization from a fair and complete perspective. Who were they? What did they achieve? And where did the practical limits of their technology truly lie? The Tiwanaku were not a primitive tribe or an isolated community living an uneventful existence in the mountains. On the contrary, they created one of the most organized and influential states in South America before the arrival of Europeans. Their civilization began taking shape in the Andean highlands around 300 AD, centered largely on the southern basin of Lake Titicaca, the highest navigable freshwater lake in the world. During its greatest period of prosperity, from roughly 500 to 900 AD, Tiwanaku influence spread across a vast territory. It covered much of the Bolivian Altiplano, reached into the fertile valleys of Peru, and extended south into parts of modern Chile and Argentina. This was a society with a clearly defined social hierarchy, a powerful central administration, and an economy capable of sustaining itself under extremely difficult conditions. Their capital, the ancient city of Tiwanaku, once supported a large population, estimated at between 20,000 and 40,000 people. Feeding so many inhabitants in the thin, cold, and dry air of the high Andes required extraordinary agricultural intelligence. Tiwanaku farmers created terraced fields along mountain slopes to capture water from melting ice and snow. They also developed raised fields with networks of water channels running between elevated planting beds. These channels helped regulate temperature and protected crops from severe nighttime frost. Their achievements extended far beyond agriculture. They produced finely crafted ceramics with a distinctive decorative style, which traveled throughout the Andes through networks of long-distance trade. The Tiwanaku also demonstrated impressive stoneworking ability through the monuments that still survive. The clearest example is the famous Bennett monolith, a towering human figure carved from a single block of stone. It stands more than 23 feet tall and weighs many tons. Its surface is covered with intricate symbolic designs carved in remarkable detail. The existence of the Bennett monolith, along with numerous other stone statues at the site, provides undeniable evidence that Tiwanaku craftsmen possessed advanced skills in carving and shaping stone. Yet, close examination of the statue reveals an important technical distinction. The carved lines on the Bennett monolith display the qualities of traditional hand craftsmanship. Many forms are gently rounded, and the marks left by cutting and grinding, although often small, remain subtly uneven. They preserve the unmistakable signs of a slow process carried out by human hands. The Bennett monolith is a masterpiece of artistic sculpture, but it is not a product of mechanical precision. This fundamental difference becomes even clearer when we make a direct geographical comparison at the site itself. The main Tiwanaku complex, containing its principal temples, massive stone walls, and partially sunken courtyards, lies only about 1,300 feet from Puma Punku. Within the main complex, the architecture is undeniably impressive. Large stone walls were assembled with considerable care, and sandstone steps were aligned with notable accuracy. Even so, these structures remain within the technological capabilities expected of a Bronze Age civilization. The stones vary in size. Natural gaps remain visible between many of the joints. The hidden surfaces behind the walls were often left rough and unfinished. These monuments appear to be the product of an enormous labor force working patiently with simple tools, pushing those methods as far as human skill and endurance would allow. But after crossing the short distance to Puma Punku, the observer encounters something entirely different. Puma Punku is not simply larger, more elaborate, or more beautiful. It appears to belong to another level of technical achievement altogether. Let us examine the problem through the mechanics of materials. Andesite, the primary material used for the most finely shaped blocks at Puma Punku, is a volcanic rock with a hardness ranging from 6 to 7 on the Mohs scale. To place that in perspective, diamond has a hardness of 10, while the metal tools available during the Tiwanaku period were made mainly from copper or bronze, with a hardness of only about 3. Even modern files made from high-quality carbon steel typically reach only around 6.5 on the Mohs scale, From a basic physical standpoint, a tool with a hardness of 3 cannot directly cut a material with a hardness of 6 or 7. When a copper chisel is struck against the surface of andesite, the softer metal begins to deform and wear away almost immediately, long before it can produce a deep cut in the stone. Creating a perfectly straight and level surface in andesite using copper tools and abrasive sand would be extraordinarily difficult on any large production scale. It would consume an enormous number of tools and would almost certainly leave behind uneven scratches, subtle curves, and natural variations caused by the movement of the human hand. Yet the surviving stonework at Puma Punku appears to challenge this entire model of manual production. The site contains surfaces so smooth and level that they resemble stone shaped by industrial cutting equipment. Some edges appear remarkably sharp, while deep channels maintain an extraordinary degree of consistency along their entire length. There are few obvious signs of misplaced hammer blows, and little visible evidence of fatigue, hesitation, or human error. This technological contrast across a distance of only about 1,300 feet raises a serious question for conventional archaeology. If the Tiwanaku built both complexes, why is there such a sudden and profound difference in the quality of the stonework? Why do the blocks in their main ceremonial center preserve the recognizable marks of Bronze Age craftsmanship, while Puma Punku, only a short distance away, appears to display something approaching industrial standardization? Could there be a major weakness in our long-accepted assumptions about the true origins of Puma Punku? To determine whether these claims of mechanical precision were more than subjective impressions, modern investigators began bringing specialized measuring instruments to the site. Among the most prominent were engineer Christopher Dunn and researcher Brian Furster, who used precision tools to examine the surviving surfaces. Their measurements with calipers and surface reference instruments were reported to show remarkably flat stone faces, with deviations measured in only a few thousandths of an inch. Such tolerances are more commonly associated with machine manufacturing than with an archaeological ruin several thousand years old. These questions eventually encouraged researchers to undertake much larger digital documentation projects. A major advance came through the work of Dr. Alexei Vranich, an archaeologist associated with the University of California, Berkeley. His research was formally published in late 2018 in the scientific journal Heritage Science. Vranich gathered approximately 150 years of historical measurements and combined them with modern three-dimensional scanning methods to create highly detailed digital models of the scattered stone blocks at Puma Punku. Using three-dimensional printing, the Berkeley research team produced precisely scaled replicas based on the recorded measurements. They then assembled the miniature pieces physically, treating them as parts of a complex spatial puzzle. For the first time, researchers were able to produce a coherent three-dimensional reconstruction of part of the original Puma Punku complex. The study demonstrated that digital modeling could do more than preserve archaeological objects. It could also reveal the sophisticated modular thinking behind the design of ancient architecture. During modern measurement campaigns at Puma Punku, specialists have also used structured light scanners, advanced instruments capable of mapping surfaces and detecting variations as small as 0.01 millimeters, or about 0.0004 inches. That is roughly 1/10 the thickness of a human hair. Similar technology is commonly used in aerospace engineering and automobile manufacturing to inspect mechanical components that require extremely strict tolerances. The numerical results produced by these scans have forced researchers to confront patterns that cannot be judged through visual observation alone. According to these measurements, some andesite surfaces show deviations of only about 0.05 millimeters across lengths of several feet. In mechanical engineering, this level of flatness is usually achieved with precision surface plates or specialized grinding machinery. It would appear to exceed what could normally be expected from stone polishing performed with abrasive sand and manual pressure alone. Second, the internal right angles of the stone blocks, especially the famous H-shaped blocks, deviate from a perfect 90-degree angle by less than 0.1 degrees. This is an extraordinary measurement, carving a deep internal corner into hard stone without breaking or chipping the edges, while preserving such precise perpendicular alignment, would be almost impossible to accomplish entirely by hand. Finally, the straight channels running across the stone surfaces maintain an almost constant depth along their entire length, with variations of only about 0.1 millimeters, or roughly 0.004 inches. The channel walls remain parallel, while the bottoms appear smooth and level. These measurements seem to display few of the characteristics normally associated with slow manual labor. Instead, they resemble the results of mechanical machining or another shaping process based on an exceptionally high degree of standardization. To understand why this standardization matters, we must consider the nature of craftsmanship itself. Whenever a person shapes stone by hand, even a highly skilled artisan, subtle individual variations remain. The pressure applied to the chisel, the angle of each hammer strike, and the rhythm of abrasive grinding all change with time, fatigue, and physical condition. As a result, every handmade object contains slight differences in dimensions, angles, or surface flatness. This individual signature can never be completely removed from ordinary ancient stonework. At Puma Punku, however, particularly among the many H-shaped blocks, the personal signature of the craftsman seems to disappear. These blocks receive their name because their shape resembles the letter H when viewed from above. Each was carved from a single piece of stone and contains a complex arrangement of channels, flat surfaces, recesses, and internal joints that may have allowed the components to lock together without mortar. These features repeat across numerous blocks with remarkably small variations, creating the impression that they were produced in groups according to a shared technical pattern. Yet the three-dimensional printing research conducted by Dr. Alexey Vranich also revealed an important detail. Although each individual block displays highly precise geometry, researchers discovered slight dimensional differences when they attempted to assemble the entire system. Some H-shaped blocks fitted together successfully, while others had subtly different proportions and could not be incorporated into the same wall section. This discovery suggests an intriguing possibility. Puma Punku may not have been a completed monument that was later destroyed. Instead, it may have resembled an unfinished construction site, or a modular production workshop, abandoned while the project was still underway. The stones appear to have been produced in separate groups, each following slightly different dimensional standards. They may have been waiting for final assembly when an unknown event brought the entire operation to a permanent halt. This line of reasoning leads us to a critical crossroads. If these blocks were produced repeatedly with surface variations of only 0.05 millimeters and right angles deviating by less than 0.1 degrees, how did the ancient builders achieve it? Did they possess powered tools and precision stone cutting equipment that later disappeared from history? Or were the blocks not cut and ground from natural volcanic stone at all? Could they have been shaped through a completely different chemical process that allowed the material to be formed inside molds? To understand more fully why conventional explanations face such serious difficulties, Puma Punku must be considered within its natural environment. Its altitude is more than a geographical detail. At nearly 12,800 feet above sea level, the atmosphere of the Altiplano is extremely thin, containing about 40% less oxygen than the air at sea level. Simply breathing in this environment places stress on the human body. Performing intense physical labor is far more demanding. Even modern workers accustomed to high-altitude conditions can tire quickly, require frequent rest, and achieve far lower levels of productivity than workers at lower elevations. Yet the builders of Puma Punku also faced the challenge of transporting enormous stones, including red sandstone blocks weighing more than 110 tons. The nearest known source of andesite lies about 10 miles from the site, across difficult terrain, divided by ravines, steep slopes, and areas with no established roads. The source of the red sandstone was even farther away, more than 50 miles from the construction area. The conventional archaeological explanation is that the stones were transported through human labor, using ramps, rollers, ropes, and large coordinated workforces. In principle, human strength organized on a massive scale can accomplish extraordinary feats, as demonstrated by the construction of the Egyptian pyramids. Yet the pyramids were built on relatively low ground near sea level, supported by the Nile River as a major transportation route, and financed by one of the wealthiest and most powerful states of the ancient world. Tiwanaku, by comparison, had a much smaller population, more limited resources, and the additional burden of working in the exhausting, oxygen-poor atmosphere of the high Andes. Even if the builders overcame the immense logistical challenge of bringing stones weighing 100 tons to the construction site, they would still have faced the problem of shaping them. Archaeologists often propose that ancient workers used diorite hammer stones, which possess a similar hardness, to strike the andesite repeatedly until the desired form emerged. This technique certainly existed in the ancient world. The unfinished obelisk in the granite quarries of Aswan, Egypt, remains one of the clearest surviving examples. Yet, pounding stone with diorite produces a rough and uneven surface marked by irregular tool impressions. To achieve a smooth and level finish, ancient craftsmen would then have needed to grind and polish the stone by hand using sand and water. Polishing a massive block through this method could require years, perhaps even decades, for a single monument. It demanded an enormous investment of labor, usually reserved for the most sacred religious projects. The vast contradiction between these logistical realities and the repeated smoothness of hundreds of blocks at Puma Punku encouraged some researchers to search for a different technical explanation. One proposed breakthrough emerged from the field of materials chemistry. In 2019, materials scientist Joseph Davidovits and his colleagues at the Geopolymer Institute in France published a controversial study. They examined samples of red sandstone and gray andesite associated with Puma Punku, using scanning electron microscopy and X-ray spectroscopy to investigate their internal structure. The laboratory results appeared to offer a radically different perspective. According to the researchers, the microscopic structure of the Puma Punku samples did not resemble natural stone formed through millions of years of geological processes. Instead, the team reported the presence of amorphous silica, organic compounds, and sodium carbonate. They interpreted these substances as signs of a synthetic binding material, suggesting that some of the blocks at Puma Punku may have been artificial stone created through an ancient geopolymer process. Under the chemical hypothesis proposed by Dr. Davidovits, the ancient builders did not quarry enormous solid blocks, carve them into shape, and drag stones weighing 100 tons across miles of mountainous terrain. Instead, they may have crushed sandstone and andesite at the quarry into fine particles. Transporting stone powder and small fragments in sacks would have been far easier than moving a single massive block. Once the material reached Puma Punku, the powdered stone may have been mixed with water, chemically reactive volcanic ash, and natural organic binders available in the region. This fluid mixture could then have been poured into standardized molds made from wood or fired clay. As the mixture dried and hardened, it would have formed artificial stone with a strength comparable to natural rock, while reproducing the exact shape of the mold. This geopolymer hypothesis offers a remarkably simple answer to the two greatest mysteries of Puma Punku. It removes much of the logistical burden involved in transporting colossal stones across the thin air and difficult terrain of the Andes. At the same time, it could explain how the surfaces achieved reported deviations of only 0.05 millimeters, and how the internal corners approached 90 degrees with variations below 0.1 degrees. The blocks would not have required extraordinary cutting or grinding tools. Their smooth surfaces and precise angles would simply have inherited the geometry of the molds in which they hardened. The hypothesis remains heavily disputed by many conventional archaeologists, who continue to favor traditional methods of quarrying, carving, and abrasion. Even so, the material evidence presented by the Geopolymer Institute has added an important scientific dimension to the debate. At the very least, it raises the possibility that ancient people possessed a knowledge of chemistry far more sophisticated than researchers once assumed. But if an advanced method of casting geopolymer stone truly existed on the Altiplano, who mastered it? Did the Tiwanaku develop this chemical technology during the Bronze Age? Or were they inheritors of a technical tradition passed down from an earlier chapter of history that has since disappeared? To search for the true creators of this sophisticated technology, we must reconsider the accepted timeline of the Altiplano. The debate over the real age of Puma Punku began more than a century ago, with one of the first Western researchers to conduct a serious investigation of the site, Arthur Poznański. He was an Austrian-born engineer who became a Bolivian citizen and devoted more than 50 years of his life to studying Tiwanaku and Puma Punku. Poznański carefully documented individual stones, measured architectural angles, and developed several radical theories. His most controversial claim concerned the astronomical alignment of the monuments. He believed that certain structures at Tiwanaku had been precisely oriented towards celestial events, including the solstices, the equinoxes, and the rising positions of particular stars. By calculating the effects of axial precession, the slow astronomical process that gradually changes the orientation of Earth's rotational axis over tens of thousands of years, Poznański reached a startling conclusion. He argued that Puma Punku had been constructed around 15,000 BC. This extremely ancient date was immediately rejected by almost the entire modern archaeological community. Mainstream researchers argued that Poznański's astronomical method contained serious errors and dismissed his theory as pseudoscience. Instead, archaeologists relied on radiocarbon dating of organic materials discovered beneath the foundations of the site. These tests repeatedly produced dates between 300 and 900 AD, placing the occupation firmly within the period when the Tiwanaku civilization reached its greatest prosperity. Yet, although Poznański's proposed date was rejected, his detailed observations of the stonework continue to present a serious scientific challenge. Even if the radiocarbon dates are correct, they prove only that people were living and working in this area between the 5th and 10th centuries AD. They do not establish beyond doubt that those same people were responsible for casting or carving the remarkably precise H-shaped blocks. This leads us to a more moderate yet compelling possibility: the theory of historical inheritance. What if Puma Punku was constructed upon foundations far older than the Tiwanaku civilization itself? Perhaps the precisely shaped blocks belong to an earlier phase of construction, created by a culture with an advanced understanding of chemistry or mechanical engineering. When the Tiwanaku emerged around 300 AD, they may have discovered these extraordinary stones already scattered across the windswept plateau. They could have attempted to continue a monumental project that they did not fully understand, producing the more visibly handcrafted structures found in the main Tiwanaku complex nearby. This break in technical knowledge may also explain why Puma Punku now appears as a chaotic field of ruins. Over many centuries, the site was looted, dismantled, and severely damaged. During the colonial period, Spanish builders removed numerous blocks for use in churches and public buildings. Local farmers also carried away smaller stones for construction on their own land. Powerful earthquakes in the Andes brought down many of the remaining structures, leaving behind what we see today, a vast puzzle from which some of the most important pieces have disappeared. The gradual decline of Tiwanaku caused the region to fragment into smaller political states before it was eventually absorbed into the Inca Empire. The original builders had vanished so completely that even the Inca could not explain where the ruins had come from. When Spanish chroniclers asked who had created the smooth and precisely shaped andesite blocks, the Inca reportedly answered with reverence that the gods had made them in a single night. Perhaps the Inca came closer to the truth than mainstream archaeology has been willing to admit. Not because supernatural beings truly constructed Puma Punku, but because the stoneworking skill and standardized design visible at the site exceeded anything the Inca themselves could understand. The difference was so profound that the work seemed possible only through the power of gods. Today, as we stand before the silent stones on the windswept Altiplano, the final answer depends upon which possibility we find most convincing. Was Puma Punku the product of a unique Tiwanaku geopolymer technology that was later forgotten? Was it inherited from an older civilization that vanished completely from history? Or was it simply the result of extraordinary human patience and craftsmanship, pushed far beyond anything modern observers have yet been able to reproduce?